In this chapter, we'll be talking about two important concepts called permutation and combination, which will be very useful later on in your further education. And in permutation, there is a symbol called NPR, and combination we have a symbol of NCR, which you can find in your calculator shift times and shift division. So you can check it out later. So the words are look very terrible, right? But indeed, so in this chapter, we are talking about counting only. We're counting something. And then so before we come to the details, let's take a look on some special terms first. And then first of all will be there's a term called sample space. So it's talking about you want to list out all the possible outcomes when you are doing a certain action. For example, if you throw a dice, so everyone knows that there are 6 results possibly. They are called 1, 2, 3, 4, 5, 6. When you talk about toss a coin, so you toss a coin one time only, then so you can have head or tail. There are 2 results. In example, in the notes, you will see that there may be some more, maybe head, 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 tail, tail, head, tail, tail. When you list out all the possible outcomes, we will call it sample space. In writing a sample space, we basically have 2 methods. One is called tree diagram, which will be demonstrated in example 1, while the other way will be using a table. We'll be talking in example 2. Now let's take a look in example 1, which you need to list out all the possible, you remember, all possible outcomes when you throw 3 fair coins. Of course, you can write it one by one, like 3 coins can be head, 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 it can be tail, 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 head, tail, tail, etc. But if you write in this way, it's not systematically enough, as well as it's very easy to miss out some items. So would there be any good way that you can write the possible outcomes very clearly? That's what tree diagram is telling you. So how it will be working will be writing in this way. So first of all, the first outcome can be head or tail. So we start from writing H and T respectively. After head, there may be 2 possible outcomes. So that's why it may be head and tail again. In this case, so you have 2 branches after the result of head in the first trial. Similarly, after the first tail, there may be head or tail as well. If you want to throw 3 coins, then you have the third layer of branches, head, tail, head, tail, head, tail, and then head, tail. So in this case, you are using a very systematical way to write down the results of throwing the coin the first time, the second time, and the third time. And then finally, you can write down the possible outcomes are, how we read head, head, head for the first one. And then you have head, head, tail for the second one. Next, you have head, tail, head, head, tail, head. Next, head, tail, head, not head, tail, tail, head, tail, tail. And then so there should be 1, 2, 3, 4 more afterward. And then so this is the way how we can write down the possible outcomes by using the tree diagram. In the case of throwing a dice, you may be using a very similar way as well. And then like when you have throw a dice, you throw a dice, you may have 1, 2, 3, 4, 5, 6. But this time it will be very terrible because after the first one, then you may have 6 branches afterward, which gives you 1, 2, 3, 4, 5, 6. 2 the same, 1, 2, 3, 4, 5, 6. 3 the same, etc. So that's why it would be quite terrible to write down the results of a tree diagram of throwing a dice. In this situation, that's why we may use a table which help us to list out the possible outcomes of throwing a dice twice, all possible outcomes. The way how we write will be, so first round maybe I put in column, and you have 1, 2, 3, 4, 5, 6. The second row I put in the first row, then you have 1, 2, 3, 4, 5, 6. So that's why we can write down the result in this way. Okay, first one, second one, so that's why we have 1, 1. And this is the first possible outcome. And next you have 1, 2. Okay, 1, 2, 1, 3, 1, 4. And you continue to write 1, 5, 1, 6. So this is a situation that if the first result is 1 of throwing a dice. The second situation will be that the first dice shows you a 2, so that's why it's 2, 1, 2, 2, etc. Then in this case, you will see that there are totally, how we can find it? There are totally 36 results where you throw a die twice. And then another important thing I would like you to take a look will be the results of 1, 2, and 2, 1 here may be considered as different because we are talking about the order of the results being shown. Is 1 first, then 2, or vice versa? So it's considered as different. So this is the case of throwing a dice. And then coming up next, you will see, maybe I give you a further example in this question. For example, later, can you help to find out how many results of them give you a sum of 7, for example? Then, so you can count. First of all, you may have 2 plus 5, so that's why 5 plus 2 is another choice. 3 plus 4, and 4 plus 3 another choice. So there are 4 possible outcomes, which give you a sum of 7. So that's why a table would be useful when you are, especially when you're talking about throwing a dice twice when you face it in the examination. The table itself, there is a drawback because we can only draw in column and row. That means you can talk about kind of like two times only. So if you consider throwing a dice 3 times, that table may not help you. So that's why tree diagram itself still very important, very useful, because tree diagram is not limited in talking about doing certain thing like throw a dice 2 times only. So for example, like example 3, you are going to list out all the possible outcomes of throwing tossing a coin 4 times. And then in this case, you can consider it's like head, tail, head, tail, head, tail. Okay, head, tail, head, tail, head, tail, or it's now 3 times, 4 times, etc. I don't write the details for you. But the question this time is not asking you to write all. Still, you need to list out the results. So I leave it as your own work. Oh, but another situation would be you are asked to talk about the number of possibilities, and then that means how many possible results can you find out. So that's why when you see when you throw a dice 2 times, throw a dice 1 time, there are 2 possible outcomes. When you throw a dice the second time, you have 2 times because there are 2 branches. So that's why it's 2 times 2, which gives you 4 times. When you throw a dice 3 times, then each branch will give you 2 more results, 2 more results. So that's why it's 4 times 2, or I write as 2 times 2 times 2, which gives you 8 times. 2 more branches times more 2, 2 times 2 times 2 times 2, which gives you 16 times. So that's why you can use these results to help you when you're talking about the question about number of possibilities. Let's take another example to see whether you understand it quite well or not. For example, if you throw a dice 2 times, then in this case, according to the table on top, you have 6 times 6, total 36 possible outcomes. But how about 3 times? Right now we say we can't use the table to present the answer, but by the principle we just mentioned, it will be 6 times 6 times 6, which gives you 216 possible outcomes. So generally speaking, you can say when you throw the dice n times, it gives you 6 to the power n possible outcomes in your answer.